All right, so we're going to get some of the technical stuff here. We talked a little about the mean of those sampling proportions. We expect them to be centered right around the real p. And then that standard deviation, remember when we were talking about a number, this was n times p, and we were talking about a standard deviation for a number, it was the square root of npq. So there's a little math here to sort of show you why if we're dividing by some constant value, that's similar to multiplying by a constant. So if you did the extra credit that was available for exam 2 in what week was that? 8, 9, week 9? Then this might look familiar to you. We're basically just multiplying by a constant of 1 over n. So we're taking these original things and saying, well, what happens if we multiply by 1 over n to each of these values? And this is what the result is these new formulas. And again, you don't have to memorize anything because these formulas are on the formula sheet for this class. So all you have to do is know if we're talking about a proportion, the mean of a proportion is p, and the standard deviation is the square root of pq over n. And as long as we have a sample size that is sufficiently large, and that rule of thumb is the same as the rule of thumb we had before, np and nq greater than or equal to 10, then we can also say in addition to x, our number of successes following an approximate normal, p hat will also follow an approximate normal centered at the mean and standard deviation on the formula sheet. So the assumptions and conditions necessary for this. Well, we do need to have a simple random sample. If we're talking about sampling people, which is what we're going to be doing from now on, we're no longer going to be dealing with like flipping coins or pulling cards. We're out of true probability land, and we're into actual inference and how we use statistics in real life. If we are grabbing people with a simple random sample, each person should be independent of the other. So these two things go hand in hand. If for some reason we're not doing this and we're more in theoretical land, we would want our observations to be independent of one another. But as long as you have a simple random sample, number 1 should be given. Another thing that's sort of counterintuitive, 3 and 4 are a bit of a balancing act. We need our rule of thumb. We need our NP and NQ to be greater than or equal to 10, so we need our sample to be large enough. But in 3, we need to make sure our sample size is not so large compared to the population. It shouldn't be more than 10% of the population. And the reason here is, if I were to take our statistics classes, and let's say there's about 70 students left after me being gone and the hybrid class format killing people off. So if there's 70 students left and I took a sample of 10, I've already broken this in terms of larger than 10%, because 10% would be 7. So this fails number 3. But if I took a sample of 10, what's going to happen is if I'm saying, figuring out the number of students who, I don't know, participate in on-campus clubs or are left-handed or whatever it is I might be counting up as my successes, technically if we're dealing with something like this, let's say we're looking at female, male, because theoretically I should know that. And let's say there are 40 females left and 30 males. If I'm doing this, I'm taking 10 people, the number of females, say we're saying what's the probability of all 10 of them being female? This is a sampling without replacement question. And technically, since I'm taking so many people, these probabilities are going to change from here to here. This is actually going to end up as a different value. But if there were 700 students, I wrote the wrong denominator, but if you get the idea, if there were 700 students, this is so close to that we can kind of ignore the issues that we don't have in terms of independence, because sampling without replacement technically doesn't have independence. So this no larger than 10% is basically so that we can ignore the sampling without replacement issues. So I know it's a bit of an oxymoron to say we need a sample big enough that we have this normality. We need NP and NQ to be greater than or equal to 10, but we also need it to be small relative to our population. Sort of seems counterintuitive to say we want it to be small relative to our population, but the reasoning is that we don't want to deal with those weird denominators that we need to be changing. there, I babbled about something we didn't do. Okay, so I'm going to take a break and we'll try the next one in another video.